So here we'll discuss the properties of movement generating function. What is movement generating function? Movement generating function is nothing but we call it as mx of v. Mx of v is equal to expected value of e power vx. It is called movement generating function. Okay. And what is the importance of moment generating function? Moment generating function is used to find out what is the nth moment. Okay, so to find the nth moment, we have two functions. First one is characteristic function, the second one is moment generating function. Okay, using these two functions, we can find out the nth moment. Now we are discussing the properties of moment generating function. So the first property is that, okay, the moment generating function at v is equal to 0 is unity. It is given as vx of mx of v at v is equal to 0 is mx of 0, that is equal to 1. Okay, so mx of v at v is equal to 0 is, so it is not there, mx of 0 that is equal to 1. Okay, so this is the first property of moment generating function. Okay, and here the we'll see the proof of this here. So what we are doing first, what is the moment generating function? The moment generating function is given by mx of v is equal to expected value of e power vx. Okay, now in this we substitute v is equal to 0. So what is that we get? Mx of 0, so that is equal to expected value of e power 0. So we know that e power 0 value is 1. Okay, so and we know that from the properties of expectation, the expected value of a constant will be equal to the same constant. So expected value of 1 will be equal to 1 only. So from this we can say that mx of v, mx of 0, so where v is equal to 0, mx of 0 value will be equal to 1. Okay, so this is the first property of moment generating function. Okay, now we see the second property. So the second property says that let x be a random variable with a movement generating function mxv. Okay, so then the movement generating function of y is equal to ax plus b is given as mx of v is equal my of v. My of v is equal to, here y, students, there is a mistake here, my of v is equal to e power vb mx of av. Okay, so we know that what is mx of v? Mx of v is expectation of e power vx. Mx of v is expectation of e power vx. Okay. Now my of v. My of v. What you have to do? X should be replaced with y here. So it is expectation of e power vy. Okay. Now what is y? Y is given as ax plus b. Okay. So now in the place of y we will be substituting ax plus b. Okay, so that we get e power v ax plus b. Okay, so we have to find out what is expectation of e power v into ax plus b. Okay, now we write this exponential separately. So if you write it separately, we get e power avx and e power vb. Yes or no? So now e power vb is constant, no? So know that from the properties of expectation, we know that expectation of ax, expectation of ax will be equal to what? Expectation of ax will be equal to a into expectation of x. Okay, so that is why if you have any constant, we can take that constant outside. Okay, so here what is the constant? E power vb, which is not having any variable. So x, y are the variables here. If you don't have variable x, then that becomes a constant here. So e power vb is the constant, so we will be writing it as e power vb expectation here, sorry, here the expectation of, okay, e power avx. Okay, so how do we write it as? Now it is in the place of v, what we have? Av, yes or no? In the place of v, now we have av. So this can be written as e power vb mx of av. So if you have only v, then this can be written as mx of v. Since we have av, so that is why we write it as mx of av. So my of v is equal to what? E power vb mx of av. Okay, so it is mx of av. Okay, this is our second property. And now we see the third property. So here the third property says that if mx of v is a moment generating function of a random variable x, then mx of cv will be equal to mcx of v, where c is a real constant. Okay, now what we know that what is mx of v? Mx of v can be written as expected value of e power vx. Okay, so it can be written as expected value of e power vx. Now mx of cv is equal to what? Expected value of e power cvx. Now v is replaced with cvx. Okay, now what we write, we can write it as expected value of e power vcx. Yes or no? We have just changed the order of multiplication here. We have taken first and cx will be having. Now you see here, in the place of x, what we have? In the place of x, we have cx, no? So this can be written as mcx of v. So mx of cv is equal to what? Mcx of v. Okay, is it clear? So then we'll see the fourth property. The fourth property says that if x1 and x2 are two independent random variables with the moment generating function mx1 of v and mx2 of v, okay, then m of x1 plus x2 of v is equal to what? It is mx1 of v into mx2 of v. Okay, so now we know that what is mx of v? Mx of v can be written as expected value of e power vx. Okay, now we know that m x1 plus x2 of v. So what you have to do here, x should be replaced with x1 plus x2. So it is equal to expected value of e power v x1 plus x2. Okay, now we write this exponential separately. This can be written as e power v x1 into e power v x2. So we write it as e power v x1 into e power v x2. Okay, so now since x1 and x2 are two independent random variables, okay, then expected value of e power vx1, e power vx2 can be written separately. These two terms can be written separately. So here we see that if x1 and x2 are independent random variables, then expected value of x1 into x2 will be equal to expected value of x1 into expected value of x2. So mx1 plus x2 of v is equal to what? Expected value of e power vx1 into expected value of e power vx2. Okay, so what is the expected value of e power vx1? Expected value of e power vx1 is nothing but mx1 of v. Expected value of e power vx2 will be nothing but mx2 of v. So mx1 plus x2 of v is equal to what? mx1 of v into mx2 of v. So this is the fourth property. Okay, similarly, if we have here, we have taken only two independent random variables. If you have n independent random variables, then this can be written as mx1 plus x2 plus so on xn of v can be written as mx1 of v, mx2 of v plus so on mxn of v. Okay, so like that we will be getting what is the moment generating function for n independent random variables. Okay, now we see this problem.